According to theCUBE research, over 65% of organizations deploying AI workloads in production cite unstructured data search and retrieval as a top bottleneck for performance and scalability. My name is Paul Nashawaty. I'm the practice lead and principal analyst for the AppDev practice at theCUBE research. I'm joined by Manuel from Qdrant. Manuel, how are you?
Hey, I'm doing well. Thanks for having me, Paul. Really excited to be here. And I lead growth at Qdrant. Some people call it Qdrant, some people call it Qdrant. I feel like our community is kind of like divided 50-50. We call it Qdrant, but whatever you want to call it is fine. Like as you just said, I think unstructured data is like kind of like a really good starting point for AI. And there's a lot of untapped potential and knowledge in unstructured data. And AI is getting embedded into everything these days, from like recommendation systems, semantic search. We're seeing RAG applications, as well as like most recently agents. And then we're also seeing it in like anomaly detection. And what all of those AI applications need is semantic understanding and meaning. And that's what we're really trying to provide at Qdrant with the help of vector search. So we're building a vector search engine that's really powering a lot of those AI applications these days. We're focusing on a lot of unstructured data and like we're trying to make it as performant as possible. We're open source. We have a pretty exciting open source community. We just reached 13 million Docker downloads this week. We have over 30,000 followers in the community, and we're also helping a lot of enterprises these days. So excited to be here and talk more about the topic.
Absolutely. Congratulations on your success. I've heard it pronounced both ways. I kind of threw that in there, Qdrant block. And I like the kind of the dynamics there. It kind of helps with like understanding for the environment. But you're right, Manuel. I mean, the vector search becomes foundational to AI powered applications. Demand for efficient unstructured data retrieval is really surging. We see our research estimates that unstructured data accounts for more than 80% of enterprise data. And with enterprise research basically forecasting that the global data sphere to reach 291 zettabytes by 2027, we really want to kind of dive into understanding, get the audience to understand this is an important challenge for a lot of organizations. So, Manuel, I'd like to start with, like when we talk about what are the primary data retrieval challenges in today's AI data-driven applications, and really how is vector search technology specifically designed to overcome these challenges? Because that's what we're seeing in our research with this data. We really need to kind of address these questions head on.
Yeah, I think that's a really good question. And 80% sounds a lot, but it's also not that surprising, right? Like think about an enterprise and like knowledge in an enterprise. It sits in documents, in conversations, in text, like a lot of emails back and forth. You have it in audio files, and then even like video formats. So a lot of different modalities, and that's all in the essence unstructured data. And if we look at like how we've done retrieval in the past, the best approach we had was keyword search, right? Which lets us search through text by looking at like certain terms. But what we need now with AI and like to really understand a lot of the knowledge in this unstructured data, it's about understanding the meaning behind the data, and doing that not only for text, but also for all the other modalities that I talked about. And this is what we're trying to solve with vector search, and it's like one of the approaches for it, because what we're basically doing is we're trying to capture the semantic meaning in like video sequences, in text parts, in documents, and trying to then start to compare them. You do that by taking those bytes, transforming them into numerical representations, which we call vectors, which are basically semantic embeddings. And with that, we're trying to start to compare them with one another. So we can now make sense of a video frame and compare it to a document or an email that was sent. And now all of a sudden, we can really start making sense of that. And this is what we've not been able to do with pure keyword search in the past. And along that, there's a lot of challenges, I think, when it comes to relevance. How do I get the right meaning and the relevance out of that? How do you think about latency? A lot of those applications really want to have, you kind of need like fast interaction, right? Like people want to have data in real time, or applications need this data in real time. How do you make that possible with searching through so many modalities and like an entire enterprise's knowledge base, basically. Same with scalability, accuracy, and yeah, this is what we're trying to address with vector search.
Yeah, it's really in the area that many organizations I'm talking, look, they're trying to uncover that scalability, the latency and relevance issues that really are prevalent with high dimensional data retrieval, right? We see this as a challenge. Many organizations are really struggling to operationalize unstructured data, especially for real-time insights. So, like, when you get asking about how vector search kind of helps bridge this gap, especially in industries like e-commerce, cybersecurity, or even recommendation engines. That's something that I think is an interesting question to ask here. Is how do organizations operationalize, and how can they look at these real-time insights from this unstructured data?
Yeah, that's a really good question, and it goes a lot about also like what are like possible use cases and like applications of that unstructured data, especially if I can get it in real time. And while vector search is really known for like helping in RAG context as the retrieval part, and like kind of helping AI applications reduce hallucination by providing real-time context, vector search was actually developed for a lot of different use cases before we had that GenAI hype 2.5 years ago. Which are also AI applications. And that is, for example, recommendation systems in e-commerce. It can be anomaly detection, trying to identify outliers with the help of vector search, because we can, on the one side, do similarity search with vector search, but we can also do dissimilarity search. So when we talk about like real-time applications, for example, in e-commerce, like GenAI is kind of like changing how people think through or want to interact with data these days. And in the past, we can apply a couple of filters and categories, for example, on an online store to find the product that we want. But we don't have this like natural interaction. Like, I want to find an outfit for a picnic on Sunday in a park, and it'll like show me that. And that's what we can actually do now with vector search, by understanding the meaning and context of the search query, and then also the meaning and context of the products, for example, that we have in an e-commerce store, and tie that together. And we're seeing that like these real-time applications in a lot of different areas. For example, when we talk about recommendations, we're working with HubSpot on their Breeze AI assistant, where they're trying to recommend and like have data accessible for customers, CRM customers, in real time. And they're basically using vector search to search through like the data in a CRM and like surface that to a customer very well. Or for example, TripAdvisor, they started to basically embed, so like turn a lot of reviews on their site, photos, images from hotels, into so-called vector embeddings. And now they can leverage those to help customers with their AI trip planning, for example. And another obviously really big topic right now, AI agents. Deutsche Telekom, for example, built a chatbot that's called Ask Magenta, which is kind of a support agent, and they're powering 2 million applications now with vector search. And it's really important to have it real time, because if you're in a customer support conversation, you want to get the information as quickly as possible, and obviously also the right context. And that's how people are solving these challenges, and like actually make like use of that data in real time for their applications.
Yeah, that question is actually very near and dear to my heart. Before I was an analyst in a past life, I helped bring a company to market that was focused around recommendation engines and search and such. And we kind of looked at things like filters and facets, and how that all worked, and why those filters and facets were important. And what we always viewed the real-time search as the search 2.0, right? Its recommendations engine is really search 2.0. And, with that said, I think when we look at, the growth in the market, there's a lot of choice here, right? A lot of organizations are out there trying to figure out how to use and optimize vector search and vector databases as part of their their overall business, right? But with the number of growing, open source vector databases and managed services, what are the biggest challenges you see vector search seeing in the market, and how does it really differentiate itself from other approaches that these enterprises are looking to achieve?
Yeah, that's a really good question. I think when it comes to the challenges like around, especially like the optionality these days, I think truth is there's a lot of applications or like a lot of solutions out there that people use for vector search, but they were actually not built with vector search in mind. And I think that's like a pretty big challenge for customers because they're running into challenges over time. So there are general purpose databases that are bolting on vector capabilities. You see search engines, traditional text search engines that are adding on like vector capabilities. But what's really important is that vectors are fundamental, the vector search is fundamentally different from like traditional approaches. And I think to understand that, we need to talk a little bit more about what is a vector and like what are like some of the characteristics of it. And I think one of the first ones is vectors are pretty heavy. So if you compare it to traditional data sets like text, you can store millions of rows and like it's pretty lightweight. When you think about a vector, they can have thousands of dimensions. They get pretty heavy pretty quickly. Like you can have a chunk of a text that represents like over 1,000 dimensions. So storing those alongside other data can very quickly overpower traditional workloads with your vector workload, which can cause memory imbalances and all of that stuff. I think the other part to understand is vectors are a transformation. So vectors are somehow obtained from source data through an embedding process. So you have documents, you have text, and you're turning that into a vector. So the vector is not the source of truth. A vector is a format that is designed to retrieve information very quickly, to compare different components and like unstructured data with one another. And so even a slight change in, for example, the model that you're using kind of like changes the geometry of the vector space. So you will end up basically reindexing the entire data. So if you're storing that along with, again, the traditional other workloads, like that overpowers it quite a bit. And then I think the third part is vectors are fixed size, which is actually quite nice. So if we're turning our data with the help of an embedding model into a vector, they all have the same dimension if we use the same embedding model. And we can actually use that for fast retrieval if we have that architecture that's designed for it, and take that to our advantage. And so ultimately, kind of like thinking about different, like what are different like offerings out in the market or like different approaches, like having a truly native architecture designed around vectors can really like unlock a lot of efficiency. We've seen that, for example, with one of our customers, Sprinkler. They kind of compare like a traditional approach with then like a native architecture, and they've seen 30% in cost reduction with a native architecture. They've seen 10x faster write performance, and also much higher throughput. And then beyond that, also when you think about the native architecture, there's even more of a difference in terms of like if your architecture is designed for vectors, there's actually a lot more features and functionalities you can build on top of that. And that's what we're trying to do at Qdrant, where we go just like a couple steps deeper, where we can optimize specific parts like the index construction with GPU acceleration, or there's a lot of new retrieval models that actually don't only output one vector, but like matrices of vectors. So you have like much more accurate data around complex documents. And like, this is something that an architecture designed for that can really handle.
Yeah, I want to double click down a little bit here though, because when organizations are evaluating vector databases, I want to touch on what you were bringing in, which is infrastructure optimization and deployment flexibility. I know you didn't use those words, but that's kind of like where my head went, right? Yeah. And I was thinking about with Qdrant addressing some of these challenges. I was thinking, especially from our briefings that we had conversations about the topics, and your latest announcements. I was really thinking about the balance between performance and cost when deploying a vector search engine at scale. But especially when I think about this, I think about it at the edge or hybrid environments. What are your thoughts around this? Because this is an area that is definitely expanding, and vector search and vector databases at the edge and hybrid environments is really becoming more and more prevalent.
Yeah, I think that's a really good question. Like maybe we can break it down into like two aspects. On the one side, like how do I optimize, and then how do I think about the deployment part? And I think what we need to is like, or like what's pretty clear, like when we talk to our community and like see a lot of different applications, there is not one size fits all vector search, or like basically every workload and application that leverages vector search has very different like demands and requirements. And we're kind of describing always, when you think about like how to optimize your vector search approach, we're kind of thinking of a triangle, which on the one side has basically high speed, on the other side it has high accuracy, and then the third component is low memory, when it's like about like how do you lower your cost. And between these three dimensions, you can basically typically pick two. So you can go for high accuracy and high speed, but then typically your infrastructure is pretty expensive because you need a lot of memory. On the other hand, let's say, for example, you have a use case like legal AI, where you're trying to understand complex documents. Well, maybe speed doesn't matter as much, but accuracy matters quite a bit. And if speed doesn't matter, I can actually make it a lot cheaper. So we have, for example, areas where you can like offload data to disk while still maintaining like a high accuracy. On the other hand, if you think about customer support, if it's like 95% accurate of a response, that's fine, but speed really matters. That's where we can, for example, apply quantization, where we compress vectors and reduce the memory usage for that, which takes a slight hit on accuracy, but overall you have a very fast response. So that's kind of how we're thinking through optimizing like the workload itself. Now, the other question around deployment, also thinking about edge, where you own infrastructure, that's another critical area that we're seeing. And also there we're seeing like every use case is different, every requirements are different. And that's what we're trying to address with like the deployment flexibility that we have. So Qdrant, you can run open source, run wherever you want. But even if you prefer the managed environment for production grade AI applications, you can either choose our managed service in the cloud. But what we've seen, particularly in the enterprise, is that they want to run their applications in their own environment. And that can have a lot of different reasons when it comes to compliance or auditability, or they want to have latency because like they want to host the application and the vector search component in the same environment for like speed and latency gains. So what we've developed is something that's called hybrid cloud approach. So we can basically decouple the control plane and the data plane. So we're deploying the database or the vector search engine into the customer's environment. All the data stays there by itself, and then you can still have a managed field through the control plane where you can do cluster operations, DevOps operations, and the scalability of things. And we're seeing that very take like a lot of demand for that. And like there's, I think also the other aspect of, you have a lot of infrastructure that you already invested in. So maybe you want to use that, and that can also help offset costs. Beyond that, we're also thinking about like we have a private cloud offering that runs fully air gap. If you really don't want to have anything leave your environment. And the way we designed Qdrant from the start, it's very lean. It's one container, and you can actually run that even on the edge and the smallest environments.
So yeah, well, there's a lot there that we talked about, especially in the last 15, 20 minutes here that we kind of gone through this section. Closing thoughts here, right? When we think about for the audience watching and talking to us, listening to this session today, there's a lot of people that are early in their journey, and some people are very mature in their journey. Where would you recommend the audience to go to learn more about what we talked about here? Because there's a lot to talk about in a short period of time.
Yeah, there's a lot of areas that you can go to. I think the best part is go try it yourself, especially if you're a learner. Like start experiencing with vectors and vectors as a data type. And like we have tutorials in our documentation pages, which you can find on qdrant.tech, where you can really get started with guided tutorials within our product. That's one of the starting points. The other part is if you want to discuss more about the concepts and you're actually like in the process of like trying it out, we have a Discord community with over 7,000 members. It's super active. You can discuss topics there, share your concerns or problems that you have. Our engineering team is right there to help as well. And then, yeah, we're trying to constantly like share new research and content around vector search. We're really just at the beginning of vector search, and there's so many more applications that we're seeing down the road. Like when we think about discovery search, dissimilarity search, there's topics around diversity search, and so yeah, follow our blog as well. And I think it's a very exciting part. We're all really excited about where this is going over the next years, and hope this was very helpful for the audience too.
Absolutely exciting indeed. It's really been a pleasure talking with you, Manuel. Thank you. This has been great. Your insights have been awesome. Lots to talk about, lots more to continue to talk about as we kind of mature this journey across the industry. But thank you for joining us, and big thank you to all of you who have tuned in. We appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode, and we'll be back next Wednesday with another conversation diving into the tools, trends, and talents shaping the future of application development. Whether you're deploying at the edge, building an AI, or modernizing your cloud stack, we've got you covered. But for now, follow us on social. And if you have any other thoughts, questions, or just want to connect, you can always reach me at pauln@siliconangle.com. Until next time, stay curious and stay building. Thank you.